In order to analyze the results obtained after a FEM simulation with CONSELF, we can use PARAVIEW, and once we have downloaded the results, we open them, we go to the PARAVIEW directory, and we open the simulation.vtm. It's a VTK file directly usable on PARAVIEW. So we open it, we click apply as usual on PARAVIEW, and in this case I have a small bicycle frame to visualize. The variables available after a statical simulation are obviously the displacement, the von Mises stress, the strain all over our structure, and the stress inside the structure. Most of the time, in order we want to see the deformation with the displacement, for that, under the filter, we type search, and we look for warp by vector functionality. In this functionality, we apply a scale factor of 100, which increase the overall displacement. Otherwise, it will be much smaller than 1 millimeter, about 0.1 millimeters in my case. We click apply, and this is the deformed structure obtained after the application of external forces. We can overimpose to that the original structure in transparency to make a comparison. So we just color it with solid color, and we go down a little bit on the left-hand side, and we apply a 0.25 opacity. 1 second, and here it is. It is possible, obviously, to have a comparison of the deformed structure against the original one, the undeformed one. If we go back and we turn on the original structure, we can see, obviously, the von Mises, the sigma von Mises, which is useful to be compared against the yield stress of the material we used. Remember, this is in megapascal, so you need some division by, sigma von Mises in Pascal, we need to convert that in megapascal divided by 1 million. So that's about 100, the maximum value I have in my simulation. And the last thing is the selection of one point in order to know the tension in that particular point, like if I want to know the tension at this place. So under view, we turn on the selection display inspector. We select to display the sigma von Mises, and we use this particular function over here by click. We have the cursor, and now we select one point in our mesh, and we are actually given the tension in that particular point, which is about 48 megapascal.